Today, our new lesson is number patterns. Lesson 1, grade 8. I will explain this lesson in two parts. This is the first part of our lesson. In this section, I will explain how to identify the number patterns as well as how to obtain the general term of the number pattern of the multiples of a number. After explaining these two objectives, I will discuss the questions given in exercise 1.2. Now we will try to identify what are the number patterns. Here I have mentioned three number series. If these are number patterns, these numbers should be written according to a certain order and they should be followed specific method or rule. Look at the first example. 3, 5, 7, 9. Are they followed any specific method or rule? Look at the first number. It's 3. Are there similar gaps between these numbers? It means 3 to 5, 5 to 7. Yes, they are specific value. It means by adding 2 to the previous number, we can form the next number. 3 plus 2, 5. Then 5 plus 2, 7. Then 7 plus 2, 9. And we can predict the next value by adding 2 to the previous number. It means 11. Then here we can identify certain rule or specific method. And also here we can identify certain order. What is the order here? These numbers are written in ascending order. Values become increase. It means value of the numbers will increase towards this direction. Then we call it as an ascending order. Now look at the second example. 2, 4, 6, 8. What is the gap between two consecutive numbers? Here it's also plus 2. If we add 2 to the previous number, then we can obtain the next number. 2 plus 2, 4. 4 plus 2, 6. 6 plus 2, 8. Then what is the next value should be here? 8 plus 2, 10. We can predict the next number by observing these given numbers. Then there is a certain pattern. Then third one. Are there similar gaps between these two consecutive numbers? No, there are no any similar gaps. Here 1, here 3, here 2, like that. But you know these are the prime numbers. Then here we used only prime numbers. By using prime numbers, we can form another number pattern. 2, 3, 5, 7. Then what should be the next number? The next prime number. What is the next prime number? It's 11. Likewise, we can write number patterns. Then if they are number patterns, every numbers of these number patterns called as terms. Terms. Then here this is the first term. First term, second term, third term, fourth term, like that. Every number is called as the terms of the number pattern. Then here also same. First term, second term, third term, fourth term, fifth term. Here I will write another example for the number pattern. Look at this. 5, 5, 5. Can you predict the next value? Yes, you can. Here also 5. It means when we are writing number patterns, there may be this type of number series also. Number pattern එකක තියෙන terms මේ වගේ සමාන වෙන්නත් පුළුවන්. If not, terms may be different like this. There are two types of number patterns. Mainly we can categorize number patterns into two types. It means finite number patterns and as well as infinite number patterns. Firstly, we will consider about finite number patterns. Here I have given two examples for the finite number patterns. Look at these two examples. First one, odd numbers from 3 to 11. Here you can observe two boundaries are given. You should write odd numbers from 3 to 11. It means the first term should be 3, then after that 5, 7, 9, 11. This is the last term of this number pattern. Can we write another more values here? No, we can't because they have given the boundaries. This is the first term, this is the last term. Then here we can identify specific number of terms in finite number patterns. Look at the second example. Square numbers. Square numbers from 1 to 16. Then this is the first one. First term 1. Second term 4. Third term 3 into 3 9. Fourth term 4 into 4 16. This is the first term. This is the last term. They have given the two boundaries. Then this type of number patterns called as finite number patterns. If we move to the second type, infinite number patterns. What are the infinite number patterns? Here I have given two examples. Odd numbers starting from 1 in ascending order. Here can we identify two boundaries? No. They have given only the first term 1. Then here we want to write the odd numbers starting from 1 and there is no end point given. 1, 3, 5, 7. Likewise you can continue. But can we write all the odd numbers here? No, it's not practical. So here when we are writing infinite number patterns, after writing 3 or 4 terms, we can put 3 dots here. After writing first 3 or 4 terms, you can put 3 dots. It means this is an infinite number pattern. It means number pattern is continuing like this. Then look at the next example. Even numbers starting from 2. 2. This is the first term. 2, 4, 6, 8. Then after that 3 dots here. We can put this symbol after writing 3 or 4 terms in infinite number patterns. දැන් මම හිතනවා ඔයාලට තේරෙනවා කොහොමද අපි අඳුනගන්නේ finite number patterns as well as infinite number patterns. This is the difference. Here we can identify specific number of terms. Here no specific number of terms. After writing 3 or 4 terms, we want to keep 3 dots at the end of writing these 3 or 4 terms. Now we will try to identify what is the general term. General term of the number pattern. In this lesson, we use another 2 similar terms instead of this general term. Common term and nth term. මේ words දෙකත් use කරන්නේ මේ general term කියන එකටම තමයි. Now we will see what is the meaning of this word general term. If we consider about this type of number pattern 2, 4, 6, 8, if we want to find the nth term, n may be any term of this number pattern, then here we can obtain a common expression for finding this value. It means the value for nth term. Here we are obtaining common algebraic expression for this nth term. ඒ කියන්නේ කිසියම් n කියලා සංඛ්‍යාවක් සඳහා අපි ලබා ගන්නවා බීජීය ප්‍රකාශනයක්. අන්න ඒකට තමයි අපි කියන්නේ general term කියලා. When the nth term of a number pattern is written as an algebraic expression in n, it is called the general term. Now we will try to obtain the general term of the number pattern of the multiples of a number. In this part, we consider only the number patterns of multiples of a number. Look at the first one. Here I am writing number pattern starting from 2 and in ascending order. 2, 4, 6, 8. Then here you know this number pattern. It is even numbers starting from 2. If not, we can explain this number pattern as multiples of 2. Starting from 2, written in ascending order. Now look at the first term. We can obtain the value of this first term 2 into 1. This is the method of obtaining the value of first term. Then second term 2 into 2. Third term 2 into 3. This is the first term, second term, third term. This is fourth one. 2 into 4. If we want to get the value of the fourth term, we want to multiply 4 by 2. Then tell me, if we want to obtain the value of 11th term, how we can obtain it? This term should be multiplied by 2. 2 into 11. Here value should be 22. If we want to find any number of this number pattern, then what we want to do here? If we write that any number as nth term, then we want to multiply n by 2. 2 into n. It means 2n. Then this is the algebraic expression for this nth term. Then this is the general term. General term. Is it clear? මෙතන මම ලිව්වේ දෙකේ ගුණාකාර රටාව. Multiples of 2. First term එක ගත්තේ කොහොමද? 2 into 1. If we want to write the value of first term, we want to multiply 1 by 2. Here second term 2 by 2. Third term 3 by 2. Fourth one 4 by 2. අපිට 11 වෙනි term එක ලියන්න ඕන නම් අපි මොකද කරන්නේ? 11 ගුණ කරන්න ඕනේ 2. මේ විදිහටම අපිට කිසියම් n කියන පදයක් නම් හොයන්න ඕනේ. ඒ nth term එක multiply කරන්න ඕනේ 2. ඒ කියන්නේ 2n. Then this is the algebraic expression for this number pattern. Now look at this second example. Here I will write the multiples of 3. Then what is the first term? It should be 3. Second one 6. Third one 9. Fourth one 12. Likewise you can continue. Then this is the first term. How we obtain this first term? 3 into 1. This is the first term. Second term 3 into 2. Third term 3 into 3. Fourth term 3 into 4. Now you can find the value for any term of this number pattern. What we want to do here? How we can obtain the general term? We want to write the algebraic expression for the nth term. Then any term, any unknown term, we can consider it as nth term. Then if the term is n, we can find the value for this term by multiplying n by 3. 3 into n. It means 3n. Then this is the general term for this number pattern. It means general term of multiples of 3. Here this is the general term for multiples of 2. Here this one is for the multiples of 3. I think now you have understood. If you have given multiples of 7, you have given multiples of 7. Then what is the general term for this number pattern? You already know this number pattern. Multiples of 7. How you can write it? 7, 14, 21. Likewise you can continue. Then what is the general term? 7n. You can find any term of this number pattern by using this general term. If you have given multiples of 8, what is the general term? It should be 8n. Likewise, now you can find the general term or common term, if not nth term, of any given number patterns of the multiples of a number. Now I will explain some of the questions given in exercise 1.1 as well as 1.2. This is the second question given in exercise 1.1. Now look at this question. Write the terms of each of the following number patterns. First one, the number pattern of the even numbers between 1 and 2, written in ascending order. Ascending means the value should be increased. Here we can write this number pattern from 2. 2, 4, 6, 8. Then here only 4 terms. Second question, the number pattern of the multiples of 6 from 6 to 36, written in ascending order. Then here we can start this number pattern from 6. Then 6 also belongs to this number pattern. 6, this is the first term. Second term, 6 times 2, 12. Third term, 6 times 3, 18. Fourth one, 6 times 4, 24. Fifth one, 6 times 5, 30. Then here from 6 to 36. It means 36 also belongs to this number pattern. 36 means 6 into 6. 36. Third one, the number pattern of the even numbers greater than 7. Then here we want to write this number pattern from 8. Greater than 7. 7 is not an even number, and also here they have given the instruction as greater than 7. Then we can start from 8. 8, 10, 12, like that we can write. But here they have not given the ending points, ending term. Then we can put 3 dot. It means this even number pattern continuing. Fourth one, the number pattern of the prime numbers starting from 2. From 2 means 2 is also belongs to this number pattern, as well as 2 is also a prime number. Then we can start from 2. 2, 3, 5, 7, like that. Here also they have not given the ending point. Then we can put 3 dots. Now look at the third question. Here they ask you to mark the correct statements with a tick mark and the incorrect statement with a cross mark. First one, the terms of a number pattern have to be in ascending order. No, it's not compulsory. The terms may be in descending order also. Sometimes it may be followed any other pattern. Then here this statement wrong. Look at the second one. The terms of a number pattern have to be different from each other. Have to be different. No, it's also wrong. Sometimes there may be number patterns with similar terms. Like this, 3, 3, 3. Then here this pattern also okay. There may be this type of number patterns. Then the second sentence also wrong. No need to be different each other. There may be number patterns with similar terms. Third one, if the 10th terms of two number patterns are different, then the two number patterns are different to each other. Yes, it's correct. If there's two number patterns, the terms of the two number patterns should be similar to each other. If not, they are in different. Then here this statement is correct. Now look at the third question in exercise 1.2. In the number pattern 11, 22, 33, 44 of the multiples of 11 starting from 11 and written in ascending order, what is the general term? Here they have given the 11th multiples, then general term 11n. What is the 9th term? They ask the value of 9th term. Then here n is equal 9. Now you can substitute value for n to this general term. 11 into 9. It should be equal 99. Then this is the value of 9th term. 9 වෙනි පදයේ අගය තමයි 99 කියලා කියන්නේ. Third question. Which term is 121? They ask what is the term. Then we can equate general term to this value 121. 11n is equal 121. Now here we want to solve this equation. Here I will solve this equation. 11n is equal 121. We can find the value for n by dividing 11. Then here we can isolate this unknown term n. Here also we want to divide by 11. Then n is equal 11. Like this we can find the term of 121. It's equal 11th term. Then 11th term is 121. Fourth one, in the number pattern 9, 18, 27, 36. Here they have given the multiples of 9. Then the general term 9n. What is the 11th term? They have given the value for n. 11th term. n is equal 11. Then we can substitute 9 into 11, 99. Third one, which term is 270? Then here we want to find the term. What is the method? We can equate general term to this value 270. Now we want to find the value for n. Then we can divide by 9. Then here we can get the answer as 30. Then the 30th value is equal 270. Now look at the sixth one. What is the smallest multiple of 3 larger than 100? The value should be larger than 100 and it should be a multiple of 3. If we write the numbers larger than 100, 101, 102, 103 like that. Now here we want to find the multiple of 3. Smallest multiple of 3 larger than 100. If we find the digital root of this number, it's 1 plus 1, 2. Here 1 plus 2, 3. 1 plus 3, 4. We want to find the smallest multiple of 3. Then here if the digital root is 369, then that number should be divisible by 3. It means this is the smallest multiple of 3 larger than 100. And ask which term is it in the number pattern of the multiples of 3 starting from 3. Now we can write the number pattern like this. 3, this is the first term, second term, 3 into 2, 6. Third term 3 into 3 9, like that. Here the last term 102. They ask which term is it in the number pattern of the multiples of 3. Which term is it? It means here they ask the term for this value. What is the term for this value? ඒගොල්ලෝ අහන්නේ මේක කීවෙනි පදයේද කියලා. They ask the value for n. Then what is the general term? Here it's multiples of 3. It means the general term should be equal to 3n. Now we have already find the value for this last term according to this number pattern. We want to find the term related to this value. Then 3n is equal 102. We can equate. Now we can find the value for n by dividing 3. N is equal, here you can find the answer as 34. It means 34th number is equal to 102. තේරුණාද ඒක ඔයාලට? මෙතෙන්දී එයාලා කියන්නේ අපිට හොයාගන්නලු smallest multiple of 3 larger than 100. 100ට වැඩි 3 ගුණාකාරය. එතකොට අපි 100ට වැඩි සංඛ්‍යා තුනක් දල වශයෙන් ලියා ගන්නවා 101, 102, 103. අපි බලනවා මේ අතරේ 3 ගුණාකාරයක් තියෙනවද? මේ පළවෙනි අවස්ථාවේ ඩිජිටල් රූට් එක හෙව්වා 2යි. එතකොට මේක 3ෙන් බෙදෙන සංඛ්‍යාවක් නෙමෙයි. Then we move to the other number 102. Here digital root is 3. It means this is the smallest multiple of 3 larger than 100. එතකොට මේක තමයි 100ට වැඩි ඊට ආසන්නව තියෙන කුඩාම 3 ගුණාකාරය. එහෙමනම් මේ තියෙන instructions වලට අනුව 102 තමයි මේ number pattern එකේ අපිට අවශ්‍ය වෙන term එක. ඊට පස්සේ අපි කරන්නේ general term එක 102 වලට equal කරාම අපිට පුළුවන් n වලට අදාළව අගය හොයාගන්න. Now look at the seventh one. What is the nth term? General term. Then nth term is also another word for this general term of the pattern of the even numbers greater than 1 but less than 200, written in ascending order. Here we want to find the general term for even numbers. It means 2n, because even numbers are multiples of 2. Then general term is equal to n. Now we want to write the number pattern. It should be even numbers greater than 1. Then we can start from 2, 4, 6, like that. The last term should be less than 200. 200ට වඩා අඩු වෙන්න ඕනේ. එතකොට 200ට වඩා අඩු even number එක ඉන්නේ 198. Then they ask the smallest value for n is equal 1. n වලට එන අඩුම අගය 1. ඒ කියන්නේ පළවෙනි term එක. What is its largest value? මේ number pattern එකේ largest value එක මොකක්ද අහනවා? n වලට එන. It means you want to find which term is 198. Then same as the above, 2n is equal 198. You can divide these two sides by 2. Then n is equal 99. මේ සංඛ්‍යා රටාවේ n වලට එන අඩුම අගය 1, වැඩිම අගය වෙන්නේ 99. ඒ කියන්නේ මේක තමයි 99 වෙනි පදය. Now look at the last question of this exercise. It has been estimated that in a country having a population of 2 million people, it means as the initial state, 2 million population as the initial stage. 2 million, here 2 million. And then the population will increase by 2 million people every 25 years. Then every 25 years. After 25 years, this value should be doubled. It means 4 million. Again, after 25 years, this value should be doubled. Likewise, this population will increase. Estimate the population of the country in 200 years. අවුරුදු 200ක් වෙනකොට මේ country එකේ population එක estimate කරන්නලු. Then this is the value for at the initial stage. 2 million people. Then after that we want to find how many 25 sets are there. It means මේ අවුරුදු 200 ඇතුලේ අවුරුදු 25 කොටස් කීයක් තියෙනවද කියලා මුලින්ම අපි හොයාගන්නවා. If we find this value, it's equal 8. Here we want to find the 8th term of this number pattern. Here look at this. This is the initial term. It means this is the first term of this number pattern. They have already given this number. Then after that we want to find how many terms? We want to find 8 terms after this value. Then this number pattern is also multiples of 2 here because 2, 4, 8 like that, no? Then you can write the general term as 2n. Here n is equal, we have already find this value 8. 2 into 8, then it is 16. After 8 years from this stage, this value should be equal 16 million people. But here already there were 2 million people. Then the total population is equal 16 plus 2, 18 million. Is it clear? මෙතන මුල අවස්ථාවේදී 2 million population එකක් තිබුණා. එයාලා අහන්නේ අවුරුදු 200ක් වෙනකොට මේ country එකේ කොච්චරක් population එක ඉඳීද කියලා. එතකොට අපි මුලින්ම හෙව්වා මේ 200 වෙද්දී 25 ඒවා කීයක් එනවද කියලා. 8ක් එනවා. ඒ වගේම මේ තියෙන්නේ general term එක 2n කියන number pattern එක. ඊට පස්සේ අපි මේ n වලට 8 substitute කරනවා. 2 into 8 16. මෙන්න මේ අවස්ථාවට පස්සේ මෙතනට පස්සේ 16 million people ඉන්නවා. අපිට 16 million කියලා එන්නේ මෙන්න මේ අවස්ථාවට පස්සේ. එහෙමනම් අපිට ඇත්තටම අවුරුදු 200 වෙද්දී ඉන්න total population එක වෙන්නේ 16 වලට මෙන්න මේ දෙකත් එකතු කරාම එන උත්තරේ. ඒ කියන්නේ 18 million population should be there. We can estimate the population of the country in 200 years. It will be 18 million. This is the end of the first part of this lesson. I think now you will be able to cover all the questions given in exercise 1.1 as well as exercise 1.2.